Today we'll continue our linear regression model, but in this lecture we start talking about how to select our variables. So we stopped in the last video when we ran our linear regression model for multiple variables. So instead of choosing all the variables, we will start to choose only the variables that have most significant impact on our y. For example, we have the room number have significant impact, but all the others is not, maybe the relationship is not obvious. So in this lecture we'll describe how to select our variables. We have two methods. The first method is when you select all the variables that have direct relationship to the y, and this is called subset selection. And the second method is called shrinkage method, regularization. Instead of you keep all your variables, but we shrink their coefficients. Make the coefficients, the beta 0 and beta 1, close to 0. Make them close to 0. Why we do that? If a variable is not very useful, its coefficient will shrink, so it has little effect. So if you have a random, if you have a noise data or the data that has not any effect on your target variables, so instead of you removing them, we just shrink their coefficient. We make the lambda is very big, so the beta 1 is going to be so small, and that's why have not effect on the target variables. And we have two methods. One is called ridge and one is called lasso. We will describe in much more detail. So in the subset selection, we have first best subset selection. We have a three method in subset selection. You select only the variables that have direct relationship with the target. We have three methods. One is called best subset selection. The best tool tries all possible combination of predictors. For example, if you have three predictors, x1, x2, x3. So it will try model with x1, x2, x3, x1, x2, x1, x3, x2, x3, x1, x2. Try all the combination between them. And then it chose the best model based on adjusted R-square. So do the combination between the variables. So if we have 15 variables, and then they do the combination for 15 variables, and then we choose the one that give you the best R-square. This is most accurate but computational expensive, especially with many predictors. Forward, the second one is called forward stepwise selection. It starts with no variables. So this method starts with no variables and then add predictors one at a time. So each time picking the variables that improve the model the most. Stop when adding more variables does not improve performance. Much faster than, but might miss the truly best combination because it doesn't recognize earlier choice. So this one, it starts with no variables and then it's add one at a time, and each time picking the variable that improve the model the most. And we have backward stepwise selection. Start with all predictors in the model, remove the less useful variables one at a time. So start with all model and then remove the least useful variables one at a time. Stop when removing more variables make the model worse. So this is work well if numbers of predictors is not huge. Can be used if you have fewer observations than predictors. So we will try to now apply this one in the R. We're gonna in the R Studio. Otherwise, you have to package leaps. So you have to install the package leaps. If you don't have leaps in your package, just go for install and write in here leaps. So just click on the leaps and click install, and you will have it. You will download it. Any packages that you don't have in the packages, just go for install and you will store directly from the crown. So let's gonna first LM linear regression for best equal to. So I'm gonna start with the first one is the best subset selection. Okay, best subset selection. The I need the model is with reg subset. So subset the price. We have the price till the all my data equal to train data, and I need my nv max equal to I'm gonna call it 15. I'm gonna run this one. So the leaps functions allow you for this is regression subset selection. This is for subset, how you choose your subset. So the model use reg subset. We have the price, we have the tilde point. The price is our y, and then this point is for our individual variables for all our x, and I need to apply that on my train data. And also I need to check my nvmax that's allow me 15. That means he will give me the summary for 15 variables. If I leave it with nvmax, he will give me only for 8 variables, but I need to check for all my variables. So if I click now summary lm best, you will see now how does this work. So we have the combinations of 15 variables, and we need to select the model that have the best R square. So in order to, if you find this one, how to look to them, and you check this one we have. So in this model, for example, we have in model number 1 we have the best it is poor Bob. In model number 2 we have we have 2 variables. In model number 3 we have 1 variables. I have 2 variables, 3 variables, and etc. But we need to check, we need to find the model that have the best R square. How to do that? So I was gonna give him summary, give me the same summary, and give me the adjusted R square, adjusted R square. Give me the adjusted R square. And here we go. He gave me all the R square for this 15 model. I'm gonna choose the best model with the best R square. So give me which dot max, give me the maximum R square. I need to have the maximum R square. If so, instead of looking for the one that have the maximum, just give him the match which max. It's allow you to give you. So model number 7. So this is 8, this is 7, point, this is 1, 2, 3, 4, 5, 6, 7. So this one, 0.708, it has the maximum R square. And this method, so you go for model number 7. So if you check model number 7, you see the variables. So we have 1 variables, 2 variables, 3 variables, 4, 5, 6, 7. So the model with 7 variables, he's give me the best R square. So instead of I choosing all the others variable, I can go in here, I will choose my room number, I will choose my air quality, I will choose, and also I will choose a distance 3. In model 7 I will choose teachers, I will choose poor prop, I will choose as a hotel bed, house bed, and I will choose the park. So this is one that have really effect on our Y. So instead of 15, now you have to choose the 7 variables. Let's give you the best R square. So this is the first method that we're talking about. It's called subset, and we have forward and we have backward. So for forward and backward, it's gonna LM underscore forward equal to sub rig. I'm gonna just drag this one the same. Okay, it's the same function, but we should add something. So rig subset price data train. So I'm gonna choose the method in here. I'm going just add the method equal to for forward, and here we go. Run this equation and then give me the summary for lm underscore forward, and here we go. It's the same, so we will do the same as we did in the lm best. Same. I'm gonna give me the sum r square, sum adjusted r square, ag adjusted r square, and then here we go. Give me which dot, I need to see the maximum, lm forward, and give me the maximum lm forward summary. Sorry for that. Give me the maximum from this one. So it gives us also 7 is the same. So and this method is also matching with that method. So this is for forward, and you can do the same for lm backward. You have just a bit in here backward. This is backward. You have to just to change the method forward to backward. And then here we go, and then in here we have to go for summary lm forward. This is to be backward. There we go, and this is supposed to be backward, and backward adjusted r maximum summary. Okay, adjusted r. Let's also give us, and then let's see which matrix lm. Okay, it's supposed to be just close this one. lm matrix lm backward. Where is the summary? Yes, that's why. Sorry for that. Max the summary, and then I'll give you the same. We give us the 7. So the 7 model for all the 3 method in this data is the best. It is the best model that give you the best r square. So this is for how we do the subset selection. And we back to the shrinkage method. In the shrinkage method, we keep all variables, but we shrink their coefficient. We make the beta 1, the slope is close to 0. Because if you have, as we said, we have noisy data, the variables that have not effect on the y, the model in here, they will give them a high beta value. Because there is very noisy data, so they will give them high beta value. So instead of removing them, you will keep them, but we shrink them, so we make them the beta is close to 0, and that's why they have not effect on our direct variables. We have 2 methods with that. The first method is called regression, and in the regression you will add the, so this is the RSS, residual sum of square is y minus y hat, as we talked in previous videos in more details. So in Lasso, in regression lasso, we will add the RSS plus the lambda and beta square, the summation of beta square. So the penalty, this is the tuning parameter, controls how strong the penalty is. And this is beta, sum of squares coefficient except the intercept. So this is the beta is not beta 0. This is the beta is represent the beta 1 that we need to change, and the beta that give us the slope, not the beta that give us the intercept. And so shrink coefficient but never make them exactly 0. This is the regression. They shrink the coefficient beta 1 but is never make them exactly this to 0. This is the ridge regression. Shrink their influence coefficient close to 0 to prevent overfitting. So, and why we do that, why we do the regression, why do the shrinkage method? Because when you run your train model and then after that you test your model on the test and scene data, so you will see there is overfitting, your model working properly in the train data but it's not working properly in your test data. So that means you have overfitting. That means you have variables and there is noisy variables and the model give them highly beta value, and that highly beta value will affect on a model. So but remember, since the penalty depend on the size of coefficient and the coefficient depend on the scale of variables, we must standardize normalize predictors before ridge. So if you need to work on ridge, you have to standardize them. You have to do the normalization. The normalization is basically to keep them from one scale, or your variables keep them the same scale. So this is the regression. You add the penalty, and we said the purpose of regularization is just to remove the overfitting. You have many predictors, the model overfit. This is training data perfected but perform poorly on the test data, as we talked before. And we have lasso regression. So lasso, it is similar to ridge, but the penalty is different. So the same, but in here he took the absolute value of coefficient. So it's the same as this is the residual sum of square plus the lambda summation of the, but he took the absolute value of coefficient. He don't do the summation, he took the absolute value of coefficient. You don't need to worry about this equation. You will have them in much more detail. So the ridge shrink coefficient but never make them exactly 0. Lasso can shrink some coefficient exactly to 0. Does variable selection like subset selections plus shrinkage together. So ridge, when you think all predictors matter a little, use ridge, many small effect, and use lasso when you think only some predictors matter, others should be dropped. So we will see how can use that in our RStudio, how to apply the ridge and lasso to shrink our coefficient, and we find the best lambda that give us the minimum lambda. In order to do that, you need to install the package called Glimt. So Glimt, if you don't know, just go for install and install Glimt. I already run Glimt. So I'm gonna start with my x equal to, so x equal to model dot matrix. Okay, I have the price and I have tilde, my data equal to train data, and as my, and I need to, I'm gonna describe it for you, no worries. So Glimt function in here for lasso and elastic, you can see that for a rig and lasso you have to change first your data from data frame into the matrix, into numeric matrix. So from data frame into numeric matrix, that's why I use model.matrix to change your in here your x data and your y so into the matrix form. His work on the matrix, so to numerical matrix from data frame and factors into numerical factor into numerical matrix. So my y equal to train data, train my y equal to, where's my train data, dollar signs price. So in here I exclude my this one -1, so I'm just excluding my y, the price. So I remove the price from the x variable, so it will be only for independent variables, and I have to change my predictors into the model matrix from the data frame into the matrix numerical matrix, and I'm working on my data equal to train data. In here, train data, I have to give him my, this is just my y, train data equal to price. First, we need to build our grid equal to, so to build our grid equal to 10 over power, this is sequence, I have to put 10, I'm gonna put -2, and gonna just put the length equal to 100, and we close that. If I print the grid now, it's gonna check and go on. So what is this a grid? Why we build this a grid? Now with this we need to find so the high value and the lower value of lambda. So I build the grid. This is 10 over the power sequence from 10, so 10 over the power 10 is 10 and -2. So this is 10 is the highest value, and I have until the -02, and I give him the length is 100 value. So I need to find the highest value of lambda and the lowest value of lambda. I give him the length is 100 value, so he give me 100 value for lambda, and then I will choose the best one from them so that fit my model, that can shrink my model. So now let's gonna just fit our model. It's called lm underscore reg equal to and glimpse equal to glimpse, and we have to give him x value, my y value, I have to give him the alpha equal to 0, and the lambda, my lambda equal to grid. So take the lambda from the grid that I built above right now. So this is a glimpse function where we add, this is my x value, my x input data, and this is where I change it to the matrix, and this is y that I need to predict for the y, and this alpha equal to 0, that means I'm using the ridge. The shrinkage method ridge is you have to set the alpha equal to 0, that means I am practicing the ridge shrinkage method. And for lasso I have to change it to 1. Lambda equal to grid, where I have to choose the lambda from my grid. That's why I built the grid first, because I need to choose the lambda that give me the best lambda. And then I have to, okay, let me check the summary. If we now check the summary in here is not gonna give us anything important, I guess. Yeah, it's nothing important. So we fit our model. Now let's gonna do a cross validation. So cross validation underscore fit equal to, let's gonna close validation dot glimpse, cross validation dot glimpse. Let me do a cross validation. So I need to see graph in here. So I'm gonna just plot my CV underscore fit I need to see the, so you can see from this the lambda and mean square error. So from this plot your data is in here. We try to find the lambda that is very close to zero, that minimize our coefficient. So it's supposed to be between this between the zero, so you can see is 0 point something in here. This is the best lambda that is fitting our model. So let's gonna find the optimum lambda. So from optimum lambda equal to CV underscore fit, CV underscore fit, dollar sign. I need lambda dot give me the minimum lambda. So instead of looking in here and check where is my lambda, if it's between this value I need the number. So to get the number it is just to drag it from here. So when I run this one, so the optimum lambda, the lambda that, where is my optimum lambda? Now we can see, I'm gonna run this one again, my optimum lambda. So optimum lambda is 0.065. So this is my optimum lambda. The is between 0 point something. This is the lowest lambda that I can get from my model, and this is that the shrink my coefficient, so I get the lowest lowest beta one. So if you can now use your lambda to get your R square. If you can use your lambda to get the best R, and you can check your lambda to build your R square and how much it can give you. So to do that, let me first just drag this one. If now we can calculate the R square. So if you calculate the R square, you need the TSS, total sum of squares, and you need the residual sum of squares, and then the R squares, it is 1 minus RSS on TD and TSS. The TSS in here, total sum of square, it is sum y minus ly mean. This is y minus ly, the mean of the y, over the power 2, and we have to predict the, this is y minus a, you have to predict the new model, this element grid, and this is the s equal to optimum lambda. So in here we told the model to take our lambda, the optimum lambda, so the lowest lambda, and then nu equal to x, and we need the nu equal to x, we need our nu x, our input data, this for x, for predict x. And the residual sum of square, sum is y minus y hat, this is the predicted one, this is the real y, and this is the predicted one over the power 2, and r square is 1 minus RSS on TSS. So if you run that, you will have the we have a new predict lm reg not found. Okay, because what is I name it in here? Okay, reg. Okay, lm reg. I have to just to change the name. Okay, so reg, and then there we go, and then there we go, and here you will find the R square that is 0.712. R square is 0.712. So this is when you check your lambda, you get the minimum lambda that to shrink your variables. Is best to put your lambda, the optimum lambda, with your predicting variables. So he will take the lowest lambda and then he will give you the best R square. So the best R square is 0.7122. And if you need to get the same things but for Lasso, if you need to apply it for Lasso, you can just do exactly the same, but you have to change the alpha from 0 to 1. All you have to do just to change the alpha and give him lm lasso and changes the alpha from 0 to 1, he will give you the same exact step, just change the alpha from 0 to 1, he give you the lasso. So this is all you need to know about how to select the variables and how to shrink your coefficient beta 0, not coefficient beta 0, will coefficient beta 1, and that's why you need to find best lambda the best lambda that is not changing, that give you the best mean square error. So if you have the best lambda, so that means you have the lowest mean square error. So, and we have the best adjusted r square. So low lambda, that mean low mean square error, and then that means you have highest r square. The error between the predicted and the true and the predicted is gonna be very low, so you need to minimize the RSS residual, the mean square error. How to minimize? By finding the beta 0 and beta 1, and if you find the lowest beta, if you find the optimum beta that minimize the RSS and use it to find your R square, he'll give you the best adjusted R square. So see you in the next video. We will start our we'll continue with supervised machine learning, but with our classification. We will start to categorize things into two steps, and then we will move to we'll move to another model like decision tree and other model. So see you in the next video.